Assalamu alaikum everyone. This is Ikram Ul Haq, computer science graduate from University of the Punjab and ambassador of deeplearning.ai Lahore. So first of all, I welcome you all to this first Pi and AI event hosted by Lahore community. And this is a virtual event obviously due to COVID-19. So thank you so much, all of you, for joining us. And this event is in partnership with deeplearning.ai. Most of you, if you are a machine learning engineer or if you have into machine learning, you must have known about deeplearning.ai. The organization is created by Professor Andrew Ng in 2017. The main focus of this organization is to teach people about deep learning. And these kind of events named as Pi and AI are hosted by communities all over the world. And this is first Pi and AI event hosted by here Lahore community. And this is actually a talk given by a speaker invited from Dubai, who is also a deep learning engineer and ambassador of deeplearning.ai at Dubai. He's also AI healthcare specialized on Coursera and mentor of AI healthcare specialization on Coursera by deeplearning.ai. So we all welcome you, Ghaith. Thank you so much for joining us.
Thank you, Ikram. Thank you.
I think you should start now. And the topic of Ghaith is solving interesting multi-travel salesman problem using RNN, and he will discuss different ways and application to solve it. Thank you so much, Ghaith. You can start now.
Okay. Thank you, Ikram. Thank you for organizing this event. I'm happy to meet you all. And in fact, it's maybe the first time I'm finding that the event is hosted by a fresh graduated person, which is very interesting. I will start sharing my screen just to show the presentation, and I will explain exactly why multi-travel salesman and what is the approach that we are going to suggest. Today, we are not giving any solution. We are not adding any value to the real world, but we are adding value to the ideas and to check how we can perform new research or make new ideas come true. Okay, thank you all of you for joining, and let's go. Don't surprise, this is my kids, and right now we will start the presentation. Right now we are talking about the multi-travel salesman problem. And to solve this problem or to trying to find a solution for this problem, we are going to focus on three approaches that are available. The first one is the original graph theory, which is something very famous and very important, and it has a lot of applications. The second, we will take a tour on genetic algorithm and what's the great about genetic algorithm and what's the bad about genetic algorithm. And then we will give one idea. Maybe it will be possible to be performed. And in fact, I'm personally interested about performing this idea. And I will be really happy if I'm able to create a team that following this idea. Is to using RNN to solve multi-travel salesman. RNN, recurrent neural network. And in fact, not to solve multi-travel salesman, but to make RNN working as a genetic algorithm. So to get the benefit of both sides. Let's go and start with the genetic algorithm. From the name, genetic algorithm is just a trial. Sorry, maybe the speech it will be a little bit long, but who is focusing on it, he will find that we are moving from more than 2 or 3 ideas. So it will be enjoyment if you are focused on it. The genetic algorithm, from the name itself, it's trying to let's say represent let's say try of matching or representing the evolutionary theory. So according to that, we are trying to create a genome or chromosome. This genome, it might be a solution for a problem, for any kind of problem. One of them, it's the multi-travel salesman problem. Or it can be the image structure or the pixels of the images. It will be stored on this genome or chromosome. Or any sequence steps, any problem that can be discrete problem, and we can just, let's say, show it as a set of sequence. So it can be stored in the genome. So the genome at the end, you can imagine it as a row with the cells. one row with the multiple cells. So the first step in the genetic algorithm is to create the genome. So according to that, we are trying to create a population, a set of genomes or a set of chromosomes. This will be the first population, and then we are trying to match or to follow the natural selection idea by creating new generations, by doing crossover and mutation and selection. And then we are going to evaluate this new generation, new solution according to that, and find which is the best. So we are trying to let the technology to let the technology go and find the solution for any problem. Okay? So in fact, this is the steps of any genetic algorithm. It's go like this. We will first create the first generation or the first population. And according to that, we are going to evaluate this population and find which one is valid solution for the mentioned problem. Okay, whatever was the problem, one of them is the multi-salesman problem or the salesman problem, travel salesman problem. And then we will, after the evaluation that we find which one is valid, which one is not accepted as a solution, we are going to the fitness function. We find which is the best solution according to that. And then we are going to reproduce a new generation by making the crossover and the mutation. And the crossover and mutation, it will be according to percentage. So sometimes we are going to copy the solution as it is to the next generation. Sometimes we are going to do crossover, which is more, it will happen more than the mutation, more frequent than the mutation. And then, or sometimes we are going to do the mutation. So according to that, new generation will be appeared. And again, it will be evaluated and the fitness function to give us what is the best solution from the new generation and go. So after, let's say, 3 or 4 or 30 generation or 40 generation, maybe we will find a very suitable solution. It's not optimal solution, it's very suitable solution. The genetic algorithm right now, it's not included into the current AI, let's say, revolutionary. But in fact, it's part of the AI because it's generating something new from which is not, it wasn't exist in the beginning. So it was part of the AI previously, and there is some reasons why genetic algorithm is right now is not used. But at the end, it's very, very good idea. If we are able to solve their problem, we are able to find great things in the future. So that's why I mentioned the genetic algorithm, and I will start with it. So just to wrap up about the genetic algorithm, we have 3 major actions we are doing while we are generating the new population or the next generation, which is the selection. We'll select which individuals we are going to use them for the next generation, either by selection or crossover or mutation. Then the crossover. The crossover, exactly, we have 2 chromosomes or 2 list of steps to tell us that this is a solution. To have 2 solutions, we are going to cut one of them and merge and cut the other one and merge them to find a new solution used by the mixed from the previous 2 and another new solution. So each 2 solution will present for us another 2 solution. This is how the crossover is happening. Okay, or we are going to do the mutation. The mutation, we have one cell with one value. For this value, it will tell us, for example, sometimes it's name of city if we are talking about multi-travel salesman, or sometimes it will be bit, if we use bit encoding, that means it's 0 or 1. The mutation, it will be changing this value from the list of the accepted value. So we are going to change the list of change the name of the city, for example. So according to that, the mutation also, it will be done. But what is the difference between crossover and mutation? Crossover, we need 2 parents to generate the new kid, for example. The mutation is just kind of mutation, which is what's happened in the viruses right now. In the coronavirus, he just changed itself. Okay, this is the first. The second, the frequency of the crossover. According, we are going to simulate the natural selection. Crossover, it's happened more probably than the mutation. For example, even for us as a human being, crossover, each day you can find it. But the mutation, until now, we couldn't find a mutation that changed the human into another, let's say, another kind of live action of another kind of animal. So the mutation, it's not that much frequent. And there is a mathematical way to find when to do the crossover, when to do the mutation. It's in the details of the genetic algorithm. And today I'm not going to go in the details because I want to reach the final idea, which is will help the rat. Okay, and then we have the evaluation function, which will tell us if this suggested new generation is accepted or not. And then what is accepted as a solution, we are going to use the fitness function just to sort them, which is the best function and which is the worst. And then we will go to the selection once again to generate a new solution until we find that we are good enough for that. Now, for the travel salesman problem, the travel salesman problem, easily we can name it as, we have a travel salesman. He wants to visit a set of cities, which is just like this point. Each point is a city on the map, for example. And then he has to find the shortest way to reach all of these cities or all of these distribution centers, whatever you can name. So the second shape is going to tell you that this is the best way to go through. So this is the original, let's say, identification for the problem. But in fact, the problem itself, it's not only for the travel salesman, but it can be used for any kind of a problem which can be embedded or represented on a graph or on a map. So one of the most important representation for the travel salesman problem, it's when we are going to use the NLP, RNN for the NLP, and we are going to do the word embeddings on the 2D graph. Okay, this word embedding is tell us which word is suitable to another one. So for example, in that embedding, we'll find that all the roots, it will be on one place or next to each other. According to that, this is a kind of travel salesman problem, but in another way. So we are talking about travel salesman problem because it's easy to imagine right now, but you can imagine how many problems it will be able to be solved using this algorithm when we find this algorithm. So this is the travel salesman problem. And according to that, the travel salesman problem, the best way to solve it is using the graph theory. And the graph theory, in fact, it's mathematical way or mathematical study that using the pairwise concept, that we are going to define a vertices or nodes or points, and these points are attached to each other with lines or edges. And this edge will tell you that this node, for example, node number 2, it has a relationship with node number 5. According to that, if we want to reach from the node, this nodes, it can be steps for experimental chemical experiment, for example, or it can be nodes on the road, let's say exits on the roads, on the map. Whatever, at the end, to reach, for example, from 2 to 4, you need to go 2, 3, 4, or 2, 5, 4. At the end, you are unable to go from 2 to 4 immediately because there is no relationship. There is nothing connected 2 to 4. And the graph theory, in fact, it has its own algorithms, and it's already, most of them, it's solved. And you can find the easiest, let's say, the easiest way or the fastest way or the shortest way from each node to another. Already it's studied, and it's part of the, let's say, wider operation research field of science. And already all of this is, and in fact, it's very great. It's very great theory, the graph theory. And we have two kinds of graphs. We have the normal graph, which is just like this. If 2 connected to 5, that means it's connected, and that's all. And here we might add some weight on the connections or on the lines, on the edges. The weight will tell you that this is the cost of moving from 2 to 5. Now this cost, it can be full functional, full mathematical function, just taking all the parameters inside it. So according to that, to move from 2 to 5, you will know exactly how much it will cost you. And the other kind is the directed graph. Directed graph, you can imagine that it's with direction. That means, for example, you are able to go from 2 to 1, but you are unable to go back from 1 to 2. So the direction, it will move you So exactly in this way, the derivative graph, it will be suitable for the travel salesman original problem more than the normal graph, because most of the routes right now, if we are talking about the routes, it will be directed. So what is the application of the graph theory? In fact, we have in the computer science, the most famous application is the network routers, is using the graph theory just to find the easiest way to the packages to go to the suitable access point or PC or whatever. And also sometimes it's a website linking method, and this is exactly, Wikipedia's have some good, and Facebook, some good examples about it, how to use the graph theory on the connection, and how to suggest that this will be suggested friend for you according to the connection from other friends. So each friend, it's a node, and if you are friend with me, for example, there is a line between me and you. So this is also another way. In linguistics, since the languages, all of the languages, it's used as discrete structure, because each word, it's standalone units. So when I say the word, for example, word itself, it's standalone unit. So anything is a discrete structure, we can go and try to represent it on the graph theory. So also it will be used in the linguistics, in physical and chemistry, and there is one in the references at the end, you can find it. There is one famous example called Feynman graph. It's from Richard Feynman, the famous physician, not a doctor, the scientist of physics, sorry, for rules and calculation. Exactly, it's used in the physics. At the end, any discrete structure can be implemented and solved by graph theory. I have some doubts about the word any, but at the end, yes, really, it has a lot of application. So, in the travel salesman, it's clear that the graph theory can help us for the travel salesman. But the multi-travel salesman, here's the problem is different, because this shape is showing you what's the meaning of multi-travel salesman. We have 3, 4, 5 salesmen, and it's their duty to cover, for example, a wide range, for example, as a full city, just like Lahore or Dubai, which is very huge city. And then one salesman is not enough to go through it, because at the end, there are something, not only the distance, the cost itself, there is a cost for him, for his time, and for his salary, and all of this. For example, we need 4 or 5 salesmen, and then we want to find the best solution that all of them together, they have to spend the minimum distance, or they will pay the minimum cost to visit all of these centers. Now, this is really critical. This is not easy. You can say by common sense we are able to solve it, but at the end, even we as a humans, and you can ask who's, for example, in Carrefour, who's able to work on the operation, this is a nightmare for them. Another nightmare, this kind of problems, it's represented for the scheduling. If you have a schedule of subject in the university lecture or something, scheduling the time. Also, it's another nightmare, because each professor or each material or each subject, it will be a salesman, and we have let's say the slots, the time slides, it will be the notes. So at the end, it's a nightmare to do it, and you can ask them. But if using the graph, not graph theory will not help us. If you find a problem, if you want a solution for this problem, even this scheduling and all of these nightmares, it will be solved. So how to solve the multi-travel salesman? One of the solutions for this is to use multi-part chromosomes on genetic algorithm. So we discussed briefly about genetic algorithm previously before reaching this, and we said that, for example, for the travel salesman, each one of these cells, it will be a city name, for example, and then one salesman, he will be able to visit the first and second and third with the sequence. For example, this is one representation for the travel salesman. But for the multi-travel, how to do it? There is one concept called the multi-part chromosome, which will tell you that you can create chromosome with 2 parts. Right now, this blue line will split the chromosome into two parts. The first part, it will be the salesman names, or for example, or codes. For example, this is salesman 1, this is salesman 2. The other, it will be the cities or the centers that he has to visit. All of them they have to visit. So how to decode this chromosome? It's like this. For example, if the value for the first salesman is 2, that we are going to understand the first 2 centers, it will be visited by him. So according to that, the second salesman, it will have another 2, and the second 2 centers will be visited by him. Now, if the value here it's changed to 3, so the first 3, it will be visited by the first salesman, and the second salesman, it will be responsible for only 1. So according to that, we have a encoding that tell us that this chromosome, it's a representation for multi-travel salesman. But this is the encoder, we talk about it. The decoder, it's how to read this code when we finish the algorithm. At the end, we want to get the results and make it explainable for the people, so we also explain it. Now, the important is the evaluate using graph theory. Now, how to find that if this solution is acceptable or not. At the end, this chromosome still suggesting a solution for multi-travel salesman. At the end, we are able to use the graph theory to find for each salesman what is the cost for him, and by summing of the costs, we will find the total cost. And according to that, the less cost, it will be the better solution. Now, there's one thing. It's the fitness at the end. We talk about it. Which is the list cost. But there is one thing: how to perform the crossover and the mutation on this kind of chromosomes. In fact, we have to deal with them as 2 separated chromosomes. So it's unacceptable to choose from the second part of chromosome some values and join it to the first part of chromosome during the crossover or the mutation or the selection. No, this is totally unacceptable. You have to make the chromosomes on 2 levels, one on the salesman level, and the second one, it will be on the centers level. For example, here is the salesman level, and this is the center. Now, here in the salesman, you can understand it in some way. We are not going to change the name of the salesman. We are going to change the centers that he is going to visit them and the count of this center. So sometimes it will be only mutation according to the representation that you are doing. This is not the only representation that's suitable for the multi-travel salesman. There is another representation, which is you are creating 2 separated chromosomes total. But this one is faster to find a solution. So we speak about genetic algorithm and multi-part chromosome for the genetic algorithm. And this is, I told you, where is the application of this genetic algorithm? In fact, it's very good for the image optimization. Right now, we have, during this month, July, you can find even on LinkedIn, on Kaggle, on GitHub, you can find a lot of researches done using GANs network. Okay, and according to that, they are able to fix and raise the quality and the resolution of the images using the GANs, and with all the tears that come when we pass Obama image and we find another white person appear. Okay, this is very good. The GANs, it's very great idea. But in fact, on image optimization, I can find genetic algorithm can play better role, because you don't need another samples. The original image only is enough, and according to that, you are able to raise the resolution for it. But at the end, it's not optimal. But I find that it can work better than the GANs for this. But the problem, we are talking about the problems later. Now, also sometimes the data labeling for languages and the data embedding, which is using the graph theory, and graph theory, it has direct relationship with the genetic algorithm. So also it can be used for that. And for sure, we are talking about the multi-travel salesman, which is, it represents a lot of problems, a lot of issues that appear. So if we are able to solve it using genetic algorithm, we will solve a lot of other problems. And also, it's very important to just check one concept, which is the taboo search. Taboo search, it's algorithm to tell you that, don't tell me, for example, in the directed graph, don't tell me that you are unable to go from 1 to 5, or for example, or 1 to 2. Tell me what is the cost if I pass from. Because sometimes I will choose to go from that way, even if it's taboo. If the cost of it, it will be less than the total cost of my algorithm. So it's very, very, very revolutionary idea that I've observed. And it's not that much used, but in fact, it's very effective. And I have some research according to that. I use that observed, but it's not in the production, it's not in the market. It was used during my academic life when I was in the university. By the way, I didn't tell you about myself. I'm Ghaith. I'm from Syria. I have a bachelor degree in AI from 2008 from University of Aleppo in Syria. And I work in Dubai, especially my focus on the healthcare sector. But general, the AI algorithms, totally I'm included on it. You can mention me on that. So what is the problem for the genetic algorithm? In fact, the first one is not suitable for real time. If we take the basic multi-travel salesman, they want a decision where to go immediately before they move. So they are unable to wait for 2 or 3 days until they get the result of the genetic algorithm. Okay. The second one, it's optimizing, but it's not optimal. That means it will give us better result, but it's not give us the better result. So according to that, this is very important to notice. We are not promising to give the better result, the best result, but yes, we are able to optimize the result to get some kind of better result. So let's go to the RNN. The RNN, recurrent neural networks, it's clear, it's understandable by everyone. I think everyone who is related to AI, he knows that RNN and how it will work and how the recurrence appears. And in fact, what is the application for the RNN, which is the NLP, mainly it's used in the NLP and linguistic research. So the idea is we have the input, which is, for example, in the languages, we have one sentence. Each word is an input, for example. And at the end, we are going to use, after the output of the unit of the neural networks, of the node, we are going to use as input for the next input. So just to unfold this shape, it will be like this. According to that, each step, this is the standard, the basic RNN. For example, for sure, we have another model for the RNN. Each step or each word in the sentence, it will be affected by the previous word. According to that, this is how the sentence is created. Because when I say, hi, I am Ghaith, to know what I'm told you, you have to understand what I say previously. So this is the RNN. At the end, we have to, why I mention about the RNN, because it have the same, say, the same a target of the graph theory, which is the discrete structure, which is the language. And we say how the graph theory can be implemented somehow in the genetic algorithm. So if we find the link between genetic algorithm and the RNN, RNN is suitable for the real time. So this is, as I told you, I'm not giving a solution. I'm not explaining something that's already exists. I'm trying to find a way to solve the multi-travel salesman problem or to implement the genetic algorithm on real time. If this has happened, and this has not happened yet, I'm just sharing ideas because I have a set of fresh minds, and this is the great thing about this event today. It's better than all the events that I met before, because all of them, they are focusing on business, on let's say on real life right now, what's happening, whatever. But I'm unable to share some new ideas. So according to that, this event, it was very great for me to take a rest from the real life. Okay, another model of the RNN is the bidirectional RNN, which is before starting the backpropagation in the training, you have to make connection between the last sentence, the last word in the sentence, for example, or the last input, and this last input will be affected to the all previous input. So the bidirectional, according to the kind of the problem that I'm trying to solve, you will choose, are you going to use the one direction or bidirectional RNN? We have multiple types of RNN, which is according to the relationship between the output this is the classification I'm going to use right now. I've done the relationship between the output and the input. So the first one is one-to-one. It's clear that we are, for example, uh, passing one input, which is one word, for example, when we are talking about, or one node, if we are talking about graph, and we will get one result. Maybe it will be a classification for this. Either it's good word or it's bad word, or this is insult, or this is kind of complementary, whatever. The other model, it's one to many, and this is not that much used, but at the end it's appeared sometimes. The next one is many to one, and this is used especially when you are going to classify or rate the answers sometimes for in the help desks for the IT team or something. There is some system comes with the rating. So the rating will be 1, 2, 3, 4, 5 according to the star rating, and this one is using RNN main. So this is how to one to many, many to one is working. Many to many, and the many to many is coming with two models. The first is either, which is here, the last one, is either the output amount or output count is the same of the input count, or the other one, it will be different. It will be different, but at the end we have, for example, 3 or 4 inputs. We are storing all of them on the structure of the RNN, and after finishing that, we are going to show another 4 or 6 outputs according to that. And this is exactly what is I'm thinking right now. I'm thinking with you what is suitable for the multi-trouble salesman problem, because at the end we have a set of centers to visit, but to go from this city to another city, maybe we have to go to third city, which is not on the list, but it's mandatory to go through. So that's why the output is not similar to the input. Now we have to make a comparison between the RNN and the genetic algorithm. Now, the genetic algorithm, we said that it's not suitable for a real-time system, but at the end, it's evolutionary. That means it's generating something which is not appear yet. You don't need for the genetic algorithm to train for training set or data set to work. At the end, you have one target and you are doing everything to reach the target. And the RNN, on the other hand, it's supervised learning algorithm. So at the end, you need data set, you need to train. Let's first why I think personally that both of them are suitable for the multi-trouble salesman, because both of them they are dealing with the sequence of information and this discrete structure of the problem. According to that, yes, since both of them able to be used in the linguistics, I found they are able to be used on the multi-trouble salesman. Now, RNN, it's suitable for the real-time system because once you train it, and okay, spend ages for training, no issues about that. Once it's trained, you are able to use it, and within a second or less than a second, or sometimes on real time, you will get the result. Genetic algorithm, no, it's not suitable for real time. By the way, even for genetic algorithm, there is some faster track genetic algorithm, another kind of genetic algorithm, which is faster from the original one. But at the end, still, it's not suitable for the range. Now, the fitness function for the genetic algorithm, it's telling you how much you far from the target that you want. So you can consider it somehow, this fitness function is a cost function for the RNN. But this is not, it's only a word, you can consider it. But how to do that? They are from different nature. The RNN is supervised learning. Okay? But genetic algorithm is not supervised learning. And somehow, if we use the cost function as the fitness function as a cost function, that means we are going to change the RNN into reinforcement learning algorithm, which is totally different family. So how to do that? It's not something easy, but I have, let's say, a vision. Maybe it needs to be implemented somewhere just to see if it's possible or not. So the RNN is implemented with validation and evaluation function. Yes, exactly. For the genetic algorithm, we have some new term, which is the evaluation function, which is tell us that distribution is accepted or not. In the RNN, we are using the evaluation itself, just evaluation, which is what is the accuracy of this, what is the specificity, what all of this evaluation method that you are going to use on the supervised learning. This one is different from the evaluation function that we are going on the genetic algorithm. And the last, building RNN that can be trained to perform the task of GN, neural network, for GN, and can be used. So at the end, we said that because both of them, they are dealing with the sequence and with the discrete structure, yes, we believe that RNN, I believe that RNN can be used to perform the genetic algorithm plan. But how? What is the obstacle? We have some problems with that. The first one is RNN is designed for supervised learning. But what we are telling previously, in the previous slide, we changed it onto reinforcement learning. The other one, where is the data set? And what kind of data set? For genetic algorithm, we're thinking about the structure and the functions or the steps that are in the algorithm more than the data that we want, because we don't need the data set. It's evolutionary. It's just kind of give me one population and I will give you the world. But on the RNN, this is not the case. We need a data set. What is the data set for? And each problem, in fact, it has different data set. And if we are talking about the basic multi-salesman problem, for each city, we have different data sets. Encoder and decoder is still needed if you are going to use the RNN. But also, it will be more complicated than the one we are using on the genetic algorithm. If the evaluation of the model is not similar, yes, exactly, this is what I'm telling you. We don't have the standard evaluation of the supervised learning models. Here, we have something else. So we need to create something. Now, one idea is first, what is the label? No, we have to make this problem, the multi-travel salesman problem, as supervised learning problem. If we are able to make this change, so we are able to solve, this problem using the RNN, and that means we will solve it in real time. And according to one of the scientists, because if we solve this problem, we'll solve all the problem of the world. I didn't agree with him, but yes, it's very important to solve this problem. So what is the label? I'm suggesting to create a kind of RNN with one output. This output will tell us that what is the cost of the suggested solution by the RNN. So the label, it will be the cost of the sequence that each travel salesman is following, and what is the, let's say, the desired label. It will be the same cost if one salesman is visiting all the cities, because sometimes this is the less cost ever if we are talking about the distance cost. So according to the identification of a problem, this will be changed, and this, what I mentioned right now, it's need mathematical proof. I don't have it right now, but it's kind of intuition. For example, we make this as a label for us, and each time we run the training, we will calculate the difference between the label that we have, which is the cost for one salesman, for the distance cost of one salesman, and for the cost of the multi-travel salesman solution that's suggested, predicted by the RNN. So according to that, we have kind of supervised learning. We change it somehow. So this will be the output. After that, we need a dictionary. We are unable to solve this problem without having a clear embedding dictionary. That means this is the center, this is the difference between the centers, this center is linked to that center. We need kind of a visualized embedding or dictionary to tell us the relationship between all the points over the city. For example, if I want to solve this multi-travel salesman all over the UAE, for example, I need to create a dictionary for all UAE. This is something not hard, by the way, because the police here in UAE, they have all of this information. They can be created. But even if I don't want to solve the problem all over the UAE, but I use this to generate data set. Also, another idea is to generate data set. So just like how in the NLP we use a dictionary, for example, of 10,000 or 100,000 or sometimes million of words to use it for example, to find the suitable answer for some question or something, or to understand the languages for language model. We need to create a dictionary of what? Of centers, of places. So our problem is visiting centers. So we need to find this kind of dictionary. It will be the original pool of the problem. And also we have to create some kind of map modeling. Now, this embedding, it's used on the, this screen, it's coming from the RNN sequence model course from Coursera, from Dr. Andrew Neg, which is one of the courses developed by deeplearning.ai. Here we are telling you how to create embedding, not one hot matrix, embedding for the word that will tell you which is the word if they have a relationship between two words. For example, we will find that queen to royal, it has 95%, but queen to food, it has 0.001, 1%. So the relationship between queen and royal, it will be more. And this is what will be used to predict when to use the word queen or when to use the word orange, for example, or strawberry. Sometimes I think it's like the strawberry. Okay, so we need something similar to the cities, in fact. We will say, or for the center, we'll say that, for example, here in Dubai, or for example, we'll take over the world. For example, I will say Lahore to Karachi is just like Dubai to Abu Dhabi, for example. So the relationship between Lahore and Karachi, it will be very strong. So we need this kind of map modeling, which is similar to the word embedding. Okay, but we are not talking about words. We are talking from the dictionary. We are talking about centers from the dictionary that we create. The other one, also we need to visualize this map embedding. So when we visualize it, we will be able to see what is, in fact, this is very easy because it's easier than the word embedding to visualize the word embedding. Because at the end, when we when we speak about the map, it's already visualized. So for the basic multi-travel salesman, this step is easier than what's happened on the NLP really. Now, for example, if we are talking about 4 salesmen, my suggestion right now, whatever I said right now, it's just kind of calculating the requirement, what we need to do that, and trying to create a basic model. But I didn't try any of it. So I'm just opening the door for all of us together. Maybe this one it will help to create something new, which is RNN for genetic ability. Okay. For example, if we have 4 travel salesmen, I'm suggesting many-to-many RNN for each one. So in case of 3, we will use for the first salesman, the same, the second salesman, the third salesman. And the input, it will be the full list of centers that all of them they have to visit. And the output, it will be also the full list, maybe of centers that which extra centers, which is not included on the list, but it's mandatory to visit according to the calculation of the genetic algorithm, for example. But with a sequence, different sequence. Now it's suggestion. Right now, this is solution suggestion. After that, we need to validate this. For example, the first salesman, he will be able to move from 1, 2, 3, 4 centers. So according to that, this solution for the first salesman is valid or not. The second for the second salesman. So we need validation layer, kind of validation layer. And then after validation, we will concatenate all of this to find one solution, and using the fitness function that we are named right now, cost function, we will find what is the final cost for this solution suggested by the genetic algorithm. And we will compare it to the label that we mentioned in the beginning, which is if all of these centers will be visited by one salesman, what is the cost? So this is kind of basic structure. It can be used for this solution. Right now, for sure, each one of these it will be trained by map embedding, just to train for the full list of tools that we have. So whatever the centers, the relation between the centers, it will be already included on the map. And also these layers, the validation layer and the fitness layer, which is can concatenating all of this together. It's only computing layers, so it's not part of the training. At the end, if there is a problem and we want to reflect this for back propagation, will be excluded from the back propagation because it's doing nothing. There is no weights here, there is no pairs here. It's only calculated. So this is the basic idea. So overall, what we need also a data set. Right now, we suggest a model. We don't know if it will work or not. But yes, it's clear that we, let's say, bend the RNN or bend the genetic algorithm to go into supervised learning. But what we need to do is supervised learning. We need a data set. And this is, in fact, this is the easy solution, the easiest way to find this if we are talking about geographic information. Because the data set is already there. If we are talking about the city of Dubai or the Emirates of Dubai or UAE, you can go to Google Maps and you can find the data set, the distance between centers, all of this will be there. The better if you have relationship with the government, you convince them with your idea, you can get all information immediately without working on it. It will be already there. Even what is the, let's say, the light column number will tell you exactly which coordination for this light column. So, for example, in UAE, this is easiest thing to get. In another countries, for example, my mother country, exactly, we know that. And one of them, really, this is something that I start working on it really, just to make the RNN or the genetic algorithm using RNN or not using RNN, not the problem here, to suggest a new neural network architecture. That means we don't need to think about how many hidden layers and how many nodes in each layer. No, we will, let's say, find a way to create a generation and let the genetic algorithm suggest for us all the hyperparameters that needed. And according to that, we will reach to neural network generated by another algorithm, not generated by one human. So this is something I start really work on it. And if we find a way to make the genetic algorithm faster, will be, I don't know what you are able to name. Also for the chemical reaction prediction, also this is also another solution. Here's the list of the references, and I will ask Ikram also to share my email. Anybody want to ask more about this, about any of these topics, not about this project only, or he is interested about this project. This project is something, by the way, it's volunteering. That means I'm working on it without any income, nobody supporting me. So anybody is interested to join me, yes, welcome. This is the reference for this, and goodbye. Any question, please? Hello.
Yeah, thank you so much, Keith. If anyone like to ask the question here, he can just unmute and talk. Anyone, please?
In developing the labels.
Hello. Yeah, your voice is not clear.
Sorry. Can you hear me?
Yes, right now, yes, it's clear.
Yes, in developing the labels, it seems like one of the problems is for realistic large networks, you wouldn't know the optimum for various configurations. Why not use reinforcement learning where you don't really need to know what the optimum is? All you need to know is that there's an improvement or not.
In fact, this is another idea. Yes, really, I agree on that. And you see, during the presentation, I told you, you are trying to print the RNN to go into enforcement learning, some kind of. So why didn't use? Maybe sometimes because maybe the reinforcement learning it will be just kind of like the same performance of genetic algorithm. This is intuition. Also, I didn't try it. Maybe I have to go for that. I agree with you that reinforcement learning is more promising as a process for this. So I agree with you on that. But maybe because it's kind of personal idea, I think RNN If we are able to build it, it will be great. But at the end, this is intuition for me. But all the scientific materials that we have, all the experiments that we did will tell you us reinforcement learning, it's better for this problem.
Another, just a comment, it seems to me like one of the benefits of this approach versus a lot of graph theoretical approaches is that most of the successful ones assume something called the triangle inequality, which is true if costs are really completely correlated with distance. But it's untrue in a lot of places, like cities. In the cities, the driving cost, or the time cost of moving from one place to another, is certainly not correlated with distance. You can have a bridge or a bottleneck or all kinds of things where different directions or times of day change those costs, and so.
Mr. Johnson.
So it seems like this approach doesn't care whether there is a triangle inequality, which is making it potentially more applicable to real life problems than many approaches that people take.
I will disagree on this because
okay.
Maybe okay, that's good you noticed that. It's good you noticed that, but because in the back end, for example, I have a back end on that. I didn't speak about the evaluation or the validation functions or methods that we are going to validate each of the salesman cost, for example. I didn't speak about it, but in fact, this is the fitness and the validation. It will be their responsibility to take care about, for example, the example that you give, which is when I talk about cities, it's not about the distance, it's about the crowd, it's about the time. It's more important, for example. So this is how to suggest or create your fitness function and evaluation function. And in fact, I have one experiment about this in genetic algorithm. It was 12 years back. We create a fitness function in University of Aleppo, a fitness function that giving the time, the shortest, for example, the result will be the shortest time for moving from one point to another. It's not the shortest distance. So this is why, okay, I can later we can discuss about it. I don't, but at the end, here's the place, the fitness function and the validation function. It will be the responsibility of them to, let's say, get the quality triangle included on this.
Yeah, but here's the thing: many approaches assume that those costs obey the triangle inequality. Your approach does not, and that's a good thing. That makes it more generalizable.
Oh, okay. Yes, on this I agree.
It makes it applicable to a much larger array of real life problems. Also, I should say, genetic algorithms also don't care about the triangle inequality, but many large TSP solvers do. That's one assumption they make to make the problem tenable for LP approaches, etc.
Yes.
So I'm saying what you're solving is a more valuable problem, even though those solvers may have solved very, very large TSPs. They're solving something that has less real world value. That's all. Just a comment. I think this is
yes. I didn't
good
hear
idea.
you well at the end. I didn't hear you well at the end. Sorry if maybe about the connection. Sorry for that. Hello.
Yes. Yeah. I'll let other people ask questions now.
Okay.
Thank you very much. This is very good stuff. Interesting stuff.
Thank you.
Thank you.
Yeah, if anyone would like to ask a question, can unmute his mic. Well, I think that's it. Gate, if you would like to share some of your words with the Lahore deep learning community, it would be great.
First, thank you. Thank you very much for this. And I hope the speech it was really opening new doors for a new approach for one of the problems, one of the most common problems. Um, Second, I'm ready anytime for any kind of cooperation, any kind of project that suggesting new solutions, new approaches for finding solutions, because this is how we have to push each other. And right now, you can see I'm in Dubai, and the investor or the host that's coming from Lahore, and we have from all over the world attendees. And this is why, in fact, thanks for COVID also pandemic. This is maybe one of the most important positive points coming to the, we are able to join together, discuss about great ideas and find great solutions together and share all of this information. So at the end, maybe we need something to push us to become a human again. This is what's happened in the COVID. All the bad, it will go, but at the end, we remember to back again to our humanity. So thank you all for joining, and I hope it was interesting and it was exciting for you for this. Thank you.
Thank you so much, Kate. It was very nice and very interesting. Hope all of the people enjoyed here. And thank you so much, all of you who joined, either it's from industry or the university students. I hope it was interesting session for you. And I want to mention one more thing, that if you have registered using Eventbrite page, you will receive an email and you need to give your feedback. After giving feedback, you will receive exciting gifts by deeplearning.ai, one of which you will receive 50% off coupons by deeplearning.ai on all the courses available on Coursera. And I think that's really interesting for industry people. The 50% discount on all the courses of deeplearning.ai and on Coursera. And thank you so much, all of you, for joining. That's all. Thank you.
Thank you.
Thanks very much.
Thank you.